Hello everyone. I hope you all are doing well. Welcome back to my YouTube channel. So today in this video, I'm going to discuss about units and dimension. So before going to understand what is unit and what is dimension, we have to understand a very important key terminology, that is quantity. So first we'll see about quantity. So what is mean by quantity? Quantity is size or amount, vastness or magnitude. Let me write. Quantity is nothing but size, amount, vastness, or we can say magnitude. Okay, I'll give an example. Okay, so in simple words, quantity is nothing but how much, how long, and how many. Okay, so we'll see a few examples. How much water is in the bottle? So suppose if you consider water bottle, how much water is in the water bottle? Sorry, how many books are there on the table? And how long is the classroom? So these are the example for quantity. Quantity is nothing but size, amount, magnitude, and in simple words, we can say how much, how long, how many. Okay, so let us move on to the main concept, that is physical quantity. What is mean by physical quantity? The measurable quantities are called physical quantity. So size we can measure, amount we can measure, vastness we can measure, magnitude we can measure, how much we can say, how long we can say, how many we can say. These quantities can be measured is called physical quantity. Okay. Okay. Here you see, we are talking about physical quantity. A quantity which can be measured is called physical quantity. Okay, what are the things we can measure? So we can take example here. Length we can measure, right? 5 centimeter, 5 meter. Area we can measure, 5 centimeter square, 5 meter square. Volume we can measure, right? Volume, meter cube. Then speed, 5 meter per second. Force, 5 Newton. Energy, 10 joule, right? This length, area, volume, speed, force, energy, all the quantities we can measure is called physical quantity. I hope you understand the meaning of quantity and physical quantity. Okay, we can give many more examples. So for example, the length of a table may be 2 meters. The speed of the car may be 50 kilometer per hour. And third example, mass of the bag may be 5 kilograms or 5 kg. Since all these can be measured, they are called physical quantities. I hope you clear with quantity and physical. Okay. Now, scientists use different systems to measure physical quantities. Okay. Earlier, different countries followed different systems. Now, we are using SI system. Okay. So earlier, I'm talking about earlier thing. So earlier, different countries followed different system. So what are those? So the first system is FPS. I'll tell you what is FPS. And second one, CGS. And third one, MKS. Okay. So what is mean by FPS? F stands for foot, P is pound, and S is second. Here also, C means centimeter, G is gram, S is second. Here, M is nothing but meter, K kilogram, S is second. Okay. Okay. Here you can see FPS system. What are the fundamental units including this system? Foot, pound, and second. In CGS system, what are the fundamental units include? Centimeter, gram, second. In MKS system, fundamental units are meter, kilogram, second. Okay. So presently we are using SI system. So worldwide. So all over the world we are using SI system. Okay. So in SI system, physical quantities are divided into three groups. Okay. No confusion in this. System of units are three. Earlier we are using only three system of units, that is FPS, CGS and MKS. Now presently in all over the world we are considering SI system. In SI system, we have three groups. Okay. So what are the three groups? Let me discuss about the three groups in SI system. Okay, these are the three groups we can see under SI system. Okay, first one is fundamental physical quantity. PQ is nothing but physical quantity. Second one, supplementary physical quantity. Third one is derived physical quantity. Let us first consider fundamental physical quantity. Okay, so consider group are a set of physical quantities. You know about physical quantities, right? Length, volume, speed, velocity, acceleration, mass. These are physical quantities. You take any set of physical quantities. So here I am taking mass, length, and speed. Okay. So consider group of physical quantities. Here I am taking one group of physical quantity. If one quantity cannot be derived from any other quantities or any remaining quantities, then that set is called physical quantity, fundamental physical quantity. An example is mass, length, time. Okay, here mass cannot be derived from length and time. Correct? So this is independent. We can't derive mass from in any other quantity. So you consider length. Length cannot be derived from this mass or time or any other physical quantity. Time. So coming to time, time cannot be derived from any other quantities like a mass or length. So these quantities are independent each other. Therefore, this set, the second set we call fundamental physical quantities. Now let us see another example. So I'll take one more example. The third example is force, length, and time. Okay. So first we'll take force. Force cannot be derived from length and time. Similarly, other quantities, length and time cannot be derived from force, or time cannot be derived from length and force. So this is considered set of physical fundamental physical quantities. I hope you understand, right? So these are the things we call fundamental physical quantities. Okay. Now, according to SI system, we have seven fundamental physical quantities. Okay. So these are basic quantities from which other quantities can be derived. So you know three basic quantities. I already explained. What is that? Length, mass, and time. By using these three, we can derive any other physical quantity. So like that, further four more physical quantities are there. Let me explain. Okay. So seven physical, fundamental physical quantity. Fundamental physical quantity. The first one is length. Okay. Second one, mass. Should maintain same order. You have to maintain the same order. Then third one, time. Fourth quantity is temperature. Thermodynamic temperature. So that thermodynamic temperature. Fifth one is electric current. So electric current also fundamental physical quantity. Electric current. Sixth one, amount of substance. Seventh one, the last one is luminous intensity. Luminous intensity. Okay, let us understand seven fundamental physical quantities. So, in seven fundamental physical quantities, first one is length. What is meant by length? Let me take an example. So, you consider point A and point B. So, there is a difference between these 2 points, right? The distance between these 2 points is measured by length. Okay, length means what? So, length measures the distance between 2 points. So what is the SI unit of length? SI unit of length is meter. So this can be represented by letter small m. Okay. Okay. Next physical quantity, fundamental physical quantity is mass. So what is mean by mass? Mass is nothing but amount of the matter present in the object. So if you consider any object, so some matter is there, no? The amount of the matter is present in the object or a thing, a body, we call mass. So what is the SI unit of mass? My SI unit of mass is kg. So how to represent mass? Mass can be represented with capital letter M. Okay. So next physical quantity is time. So what is mean by time? The gap between two interval is called time. The gap between two interval is called time. SI unit of time is second. The unit symbol is smallest. Okay. Next, the fourth one, thermodynamic temperature. You know about temperature, right? The degree of hotness or coldness of the body is called temperature. So thermodynamic temperature also same. Okay, what is the SI unit of temperature? Is Kelvin, not Celsius, it is Kelvin. So unit symbol is K. Okay. Next, electric current. What is mean by electric current? So how many electrons are flowing in per unit time? So how many electrons are flowing in a second is called electric current. Otherwise, we can define rate of flow of charges. Okay. So what is the SI unit? Ampere. The symbol, unit symbol is capital A. Thermodynamic temperature, capital K. Time is small s. So usually we will write sec, correct SEC. No, this is not a correct way to write SI unit. SI unit of time is small s. The unit symbol and temperature unit symbol is capital K. Current unit symbol is capital A. Okay, next, amount of substance. Number of particles in a substance. How many number of particles are present in a substance is called amount of substance. So SI unit is mole. Okay. So unit symbol MOL. SI unit MOLE. Unit symbol MOL. Okay. Next, last one, luminous intensity. Intensity means what? Brightness. Okay. Luminous means what? It's related to light. Okay. So from by these words, we can define luminous intensity as luminous intensity measure brightness of light. What is the SI unit? Candela. Unit symbol is CD. Small c, small d. So candela is the SI unit. Unit symbol is small c and small d. Okay, this is all about fundamental physical quantities. So in SI system, we have two more physical quantities, that is supplementary physical quantity and derived physical quantity. So now let me discuss about supplementary physical quantity. Supplementary physical quantity. In supplementary physical quantity, we have two quantities. One is plane angle. Plane angle. Another one is solid angle. So second one, solid angle. So I'll tell you the difference between solid angle and plane angle. First, we'll discuss about plane angle. So SI unit of plane angle is radian. So sir, that unit symbol is rad. Okay. SI unit of plane angle is radian. What is mean by radian? Radian is defined as the angle subtended at the center of the circle by an arc whose length is equal to the radius of the circle. Okay, sounds difficult. Don't worry, let us discuss this radian in simple words. Just you take a circle, this is a circle, right? This is the center of the circle. See, what is this? Radius. Correct? Huh? So take a radius of the circle and measure the arc on the boundary. So this is the arc. Now measure the arc. Okay, like this is arc. This is also arc. Okay, take a radius of the circle and measure the arc on the boundary that equal to the radius length. Okay, the angle formed. This is here angle will form. The angle formed at the center by the arc is called radius. Okay, so just you draw circle, mark center of the circle, and you draw one line which joins center and boundary of the circle. That one we call radius. Then you identify one arc. Okay, so angle made at the center is called radius. So 1 radian is equal to how much? 1 radian 1 radian is equal to 360 degree divided by 2 pi. 1 radian is equal to 360 degree divided by 2 pi. What is the actual value in degree? That is 57 degree. Okay. What is the formula? So you can write formula also. D theta is equal to ds by dr. R is the radius. So ds is the distance from this point to this center. Okay. So the plane angle is the ratio of length of r to the radius r. We can write definition. What is the definition? This is only plane angle. So what is the definition? Plane angle can be defined as ratio of length of arc to radius of circle. Okay, I hope you clear about plane angle. Okay, next, what is mean by solid angle? SI unit of solid angle is steradian. Okay, SI unit of solid angle is steradian. Okay, so just you consider a sphere. Okay, suppose we have a sphere. If portion of the sphere surface is equal to radius of square. Okay, so is equal to radius of the square, creates an angle at the center. Then the angle is called steradian. So I'm giving definition for steradian, not for solid angle. Okay, this is a sphere. If portion of the sphere is equal to square, what is that? Radius of a square. Okay, this is equal to radius of the square. Certain angle at the center. So certain angle at the center. Then the angle is called steradian. So from this, what we can write a definition for solid angle? Solid angle is the ratio of surface area to the square of the radius. Okay, so I can write solid angle. Let me take solid angle is equal to ratio of surface area, SA, surface area to square of the radius. This is the formula for solid angle. SI unit of solid angle is steradian. Okay, now let us discuss about derived quantities. You know about fundamental quantities, right? 7 fundamental quantities and 2 supplementary physical quantities. So apart from these 7 plus 2, 9 quantities, remaining all the quantities comes under derived physical quantity. Okay, so let me discuss about derived physical quantities. Okay, derived physical quantities. The quantities that are derived from fundamental physical quantities and supplementary physical quantities are called derived physical quantities. Okay, in simple words, these quantities are formed by combining basic quantities. What are basic quantities? 7 physical quantities are fundamental physical quantities and 2 supplementary physical quantities. By combining these two, we can get this derived quantity. Okay, example. So many examples we can list here. So first one, I'll take force. So how do we say force is a derived physical quantity? So first you write the formula for force. F is equal to ma. Right. So what is m? Mass. A is acceleration. Okay, mass is what? Fundamental physical quantity. Fundamental physical quantity. Then acceleration. We can write formula for acceleration now. So what is the formula? Velocity divided by time. So what is time? Time is a fundamental physical quantity. So we can write formula for velocity. What is that? Distance divided by time. How to measure distance? How do we measure distance? By using length. Correct? Meter per second. Time. Meter by time. Time is what again? Fundamental physical quantity. So what is this? Meter, length. This is also fundamental physical quantity. You can see here, force is derived from mass, time and length. Okay. So by these three physical quantities, using these three fundamental physical quantity, we can derive force. Okay. Second example is about volume of cube. So you know the formula, right? In cube, all the sides are equal. Can I write length into breadth into height as L into L into L? Okay. So this cube is derived from length into length. So this length is a fundamental physical quantity. By using these three fundamental physical quantities, we can derive volume. Okay. Next, let me take one more example. Very easy one I'll take now. Area. So you consider I am taking area of a square. What is the formula? Length into breadth. So instead of writing L into B, I am taking L into L. Why? Because all the sides are equal. L into L. This L also fundamental physical quantity. This one also fundamental physical quantity. By using these two, we can derive area. Right? I hope you understand about derived physical quantity, fundamental physical quantity, and supplementary physical. So you just assume these fundamental physical quantities, seven physical quantities are like the alphabet. These are like a alphabet. Okay, in English, alphabets are basic building blocks, right? Like that, these seven physical quantities, fundamental physical quantities are basic quantities in physics. By using these seven physical quantities, we can derive derived quantities. We can get derived quantities. Okay, these derived quantities are words. By using seven physical quantities, we are deriving, we are framing the words. So without alphabet, we can't form words. Okay, without alphabet, we can't form words. So in the same way, without fundamental physical quantities, we can't derive any other physical quantities. Okay, so this is very important concept in physics. So students, today we learned supplementary physical quantities, fundamental physical quantities, and derived physical quantities. In next class, we will continue with some more concept related to units and dimension. Thank you everyone. Have a good day.